Hi, my name is Darren, and today I want to talk to you about DevOps. Probably not in the way you're thinking, though. I'm going to assert that we've been looking at it the wrong way. More accurately, our focus has not always been in the right place. There are some really high value add activities and outputs that come from this that are centered around the customer, and I think we can use those to release new features faster. So before we dive into that, let me introduce and say that I'm actually a longtime Java developer. About 7 years ago, when I started working at Amazon Web Services, that's when I was introduced to Ruby and Rails. And really, I've never looked back. I was hooked. The Ruby community is so welcoming. It's really been great. And I'm so lucky now in my current role, I get to work with Ruby and Rails, talk about it, write about it, and share all of that with you. At some point in my journey, I realized that when I was writing some code to do a random task, maybe to like crank through some data, do a little bit of analysis, some kind of CM script, whatever it might be, I was writing it in Ruby and not another language. So it just kind of clicked, like learning how to ride a bicycle, learning how to swim. All of a sudden, you just know how to do it. That was me. All of a sudden, Ruby was my go-to language, and really, I've never looked back. It's like anything in technology. You apply what you know to solve the problem at hand. So you won't find Ruby at the bottom of the public cloud stack per se. It's not turtles all the way down and then there's Ruby at the bottom. But we know it can do so many things. Obviously web apps, but testing, configuration management, and ops tooling. And those things tie into our topics later. So more on that to come. So let's go back to 7 years ago when I was taking the job at AWS. I was going into the EC2 group, and specifically I was going to work on VPC, or Virtual Private Cloud. So I thought I was smart. I wanted to prepare and be ready on day one, impress everybody. So I went out and I bought a book on software-defined networking. It's a very good book. I do recommend it. I also contacted my hiring manager, who I then went on to work for a few years, Mahmoud, fantastic manager. And I asked him, Mahmoud, hey, what can I do to prepare and get ready? So I was thinking, I'd be right in line. He actually said something different. He told me, Darren, use AWS, use VPC, use it as a customer, learn it. What do you like about it? What do you not like about it? When would you use a private link versus VPC peering? Why do they both exist? I was actually looking at things more internally focused. How can I learn a skill that I can apply from a technology perspective? And what he was telling me was more external focused. How does a customer look at that product or that service? Looking at it from the outside in. And so we're going to build on this theme further through our talk and through our time today, because that is really how you gain incredibly valuable insights to your software products and services. So we have this balance between internal concerns, building our software and deploying it, and external concerns. How do customers use our software? What is their experience like? What works well and what doesn't? So to me, the true value of DevOps is actually that it brings these two things together. It unifies them so that we can gain those insights that otherwise we wouldn't be able to get. These are things that you can't easily just learn from reading a book or taking a training class, in part because they're going to be unique to your service and its characteristics, to your product, the features that you offer, and how customers react to those and use those. So what is DevOps then? What is actually going to be the glue that brings these things together? Well, as many of you I'm sure know, it's many different elements. That's what people think of it. Certainly the collaboration between development activities and production or maintenance. Now these used to be oftentimes different people, different teams that did this. More commonly now it's the same individuals. And I would strongly advocate that it is, in fact, the same individuals, because that is one of the best ways to get the insights to seeing how customers use your service. But certainly DevOps also includes processes, automation, tools, all of these different aspects, and they're all great stuff. But we want to be asking the question, what is the value that they provide? So today you really do want to be relentlessly focused on your customer, innovating quickly, adding new features and capabilities, fixing any issues that come up. Because before pandemic, we were already approaching this, but we're almost entirely in a digital economy now. Things move fast. Your competitors can copy your business model if you're sitting around complacent for too long. You want to be able to move quickly. DevOps is going to help you do this. When we think about that though, the focus to me on the operations part, I think oftentimes it becomes synonymous with deployments and CI/CD. Now, again, these are very valuable things that save manual time and effort. But the true focus should really be on the operations, fine-tuning our service, learning how customers interact with it. How do we do this? We look at metrics. We can see what alarms are triggered and when, what patterns exist. When do we have issues? When do things work well? You can actually learn a lot about your service just from looking through the ticket queue. What are customers asking for? What are they saying that doesn't work? Actually, even more valuable is what are they confused by? What did they think they were going to do and things didn't work the way they expected? Those are areas where you can really reduce the friction and make things a lot better for you and your customers in the process. Now, engineers typically, they don't always get that exposure. I know that many engineers I've worked with often want more exposure to the customer. They want to be, or even the product managers who are a proxy for the customer. It's very easy to get inside of that internal bubble, and we use the term bubble for happiness because that's where we're coding in our Ruby and Rails. But basically, we want to expand that bubble to not just the development of our apps, but also to how we operate them, how we get them into our customers' hands. Because again, that's where it gets really exciting. Now, this is true for web applications that are end user customer facing. If I'm selling books online, for example, or if I'm building tools or frameworks, remember that it's just you have different customers. Your customers may actually be other developers. When I was at AWS, many of the customers were other internal services, other AWS services. So you have to think about who is your customer really, and that's who you should be focused on. Sometimes this isn't always so clear. It's worth giving some thought to. So how does all of this impact our development and operations? Well, with what we learn, we generally do two things. We're fixing problems that come up, and we're adding new features and capabilities for our customers. So let's take a step back. How do we position ourselves for this? So we design our software up front. There's really only one reason that we do design. It's not so that we can have great looking architecture diagrams. It's not so that the code is aesthetically pleasing. I mean, both of these things are great side effects that those of us who value the craft really enjoy. But the real reason we do design is because we're going to need to change our software tomorrow. We want to do that quickly, cleanly, and as safely as possible. Separation of concerns is important, and Rails gives us a great starting point here. It can't do everything though. We still need design and discipline on our process and our teams. At this point, for example, it's hard to imagine having a project without all of the code going through code reviews. I mean, it's just hard to imagine that at this point. Rails by itself, it can't prevent your helpers directory, for example, from becoming a dumping ground for every random method that people think of or that they need. I will say, at least having worked on so many different projects where different things like string helper classes show up, Ruby's great because the string class and so many others are feature rich that you don't need that type of thing. But this outline that we've got, unfortunately, it can still get to be like the outline of a picture in a coloring book. It's pretty easy to color outside the lines, even use a different color theme, or go way outside what you originally intended. Every design decision that we make then should be through the lens of separation of concerns for the purpose of being able to make those changes tomorrow. So here's an important point. Every design construct that we put in, there actually is a cost to it. Layers of indirection, other kinds of patterns, they're not free. They add to the complexity of the system. So you want to think through when it makes sense to do that. What does it make sense to abstract? And to do this, you can focus on what are the areas where you're going to want to innovate in your product? What are the areas where they might go through rapid change? You can't predict all of these up front. You can make some probably pretty good educated guesses. And then this is where DevOps comes in, because you observe how your customers are using the system. What are they more focused on? Where are they spending more time, or what are they having problems with? Then you can put more design energy and effort in those areas. As an example, I've been on a project before where they took indirection and abstraction a little bit too far. When I was looking in the code to try to find where the actual work was being done, after I got 9 layers deep in the stack, I almost forgot what it was that I was looking for. Now, they used a lot of good design patterns. They followed, I guess you could call it best practices. The methods were very small. Generally speaking, you don't want a method to be longer than a visual page worth of code. All of that was true, but it was extremely difficult to follow what was actually going on. And I'm pretty sure that those 9 layers of indirection didn't all need to be modified or changed at different points in the life cycle. It wasn't adding value, it was just adding complexity. Now, when you search for Rails anti-patterns or best practices, you're going to find a lot of things that say, don't put too much code in your controller, or your model class, or your view, whatever the case may be. These things are really guidelines. I don't know that they're necessarily best practices. Your mileage is always going to vary. It's like when you're in school and the teacher says, okay, you're going to have to write a paper on, I don't know, the 1920s, pick a topic, and people look around in the class and then someone asks, well, how long does the paper have to be? And the teacher says, well, as long as it takes to explain the topic. And everyone's like, ugh. So not everything, there's no one size fits all to these things. You always have to apply what makes sense to the situation. This is especially true for controllers. So we're going to shift gears and get a little more tactical now. Here is a diagram of the basic Rails architecture, and a good general guideline is that you want to push logic as far down in this diagram as you can or as makes sense. The top is closest to the user interface, the bottom of the diagram closest to the system and the infrastructure. So now back to our controller method. If an individual method takes 2, 3, even more pages of text, I have no problem with that if that's what's required to implement that workflow. Just like if that's how many pages you need to describe something about the 1920s in school, that's what you should do. And I am singling out services here. I'm using controller actions as roughly synonymous with services because I believe they play a special part in the architecture. When a user takes an action, clicks a button, controller actions, our services, logically speaking, are the direct recipient of that. They say, okay, I'll take care of that for you. They're asking for a specific thing. So these controller actions, the services behind them, provide a great mechanism for reuse and decomposition. You can certainly delegate the work to a class that's independent of the HTTP protocol, those parameters, or the specific routing endpoint. I don't think that's the most important bit though. The most important bit is that this is how humans logically think about services or about systems. They more closely resemble the real world. As an example, if I'm going to go online and pay a bill, let's say pay my credit card, I don't really think about it in terms of, well, there's an account object or an invoice that has a pay method. I'm just thinking about, I'm going to go pay my bill. Now, without a doubt, underneath all of that are those corresponding model classes that encapsulate the validation, any other logic that always takes place when those get updated, and that's perfect and great, and we should continue to do that. But from a large scale, when we're reasoning about the system, those services provide a great way to think about it, to implement it, and reuse capability. Now, I wouldn't do this, but let's say that I paid my bill late or I forgot to do it on time. There may also be then a need to calculate a late fee. That could be another service. And in each of these services, you can think of those as this little encapsulated box where within that we think about how do we push logic as far down as we can. And then we can of course layer these services as much as we need to. This gets more closer to the service-oriented architecture, depending on the size and scope of them, microservices. If you have a lot of these, you may want to look at tools or other things to help you manage all of them, but it's a great way to decompose your system. So here's one really cool thing I like about Rails. You might be saying, well, Darren, I work on an existing application. It's a large code base. I don't have the luxury of doing greenfield design or making some of these changes that you're talking about. That's okay. Rails has some great tools to help you here. And Rome wasn't built in a day. All of these things, all of these migrations, architectural changes happen over time incrementally. So now let's look at some code. I know you're like, finally, Darren, you're going to show us some code. Here is a quiz controller. I have a Ruby quiz application that I use for a lot of my content. It just goes through a series of questions and keeps track of how many correct answers you get. So what we're going to do is look at a new method that I added on here called summary. And you can route to it. So think of it as a microservice that does some reporting. I want to add some visibility to my quiz so that an administrator or an owner of the system can go and look and see, well, how are people doing? Are they scoring well on the quizzes? Are they even actually completing them? So this is some code to query the database and do some very simple calculations, calculate the average, and show how many participants there were. So here's the really cool part. Let's say I eventually want to build an entire reporting subsystem. I want to segregate that out. What I can do is create a separate microservice for that, and I can do it really quickly. So this here is the normal rackup file that you use, config.ru. Pretty boring, right? It just does run Rails application. If you switch this now to use the quiz controller action, that action method, again, is its own rack application. And now that endpoint, when you deploy this, is its own microservice. I just reused all of the code, all of the model objects, but logically speaking, I got a new microservice that from a system perspective, I can start to migrate to that architecture and move toward where I really want to end up being. I don't have the physical separation yet, but there's a great way that you can do that. If you start to use containers as your deployment mechanism, this becomes really nice. So from the same container image for this repository, what you can do is the script that runs the command, rather than running pretty much the default rack, which uses the basic config RU, you can specify a different config RU that uses this rackup file. And now you have a new microservice that you can deploy separately in its own container instance. It will scale independently, and you get some really nice advantages. You can observe that more closely, get metrics and monitoring on that particular microservice separate from your web application. Where does this really come in handy then? If we're running a monolith application in our production environment, let's say we deploy some changes. Perhaps you have some changes to the web application, maybe a service, and even a sidekick job. Now your new version is deployed and CPU on your instances begins to spin. It goes up to 100%. There's two bad things with this scenario, or at least two bad things. One is that your blast radius was pretty big. You just impacted all of the components of your system. Your customers they can't use your web application. None of the background work is being done. You're going to fall behind on that. Customers are not happy. So you definitely need to roll back so that you can mitigate the customer impact. Now, the second bad thing is that you don't immediately know where the problem was. If you had a few changes bundled in that release, just by looking at the metrics, it's not immediately obvious unless you've really done some nice fine tuning on those and your alarms are in good shape. If you have different containers, you're going to be it's going to be easy to spot which one caused the problem. You can even deploy them separately, so you can do it from a timing perspective. But even if they all went out at the same time, you're going to see which of those is causing the CPU to be elevated. It's also going to reduce the blast radius because your other components are not going to be impacted. So if your web application is taking customer orders, that can still be up and running. Maybe your background process that had the issue, let's say it's there, that may fall behind a little bit, but we can roll that back, continue to do the work, and diagnose the problem. So all of this we get just by adding another copy of the Docker file to run a different command. Again, we reused all of the code. On a platform as a service like EngineYard, this is even easier. It's just another entry in a proc file. So from that same container image, it's saying run that process for this container type. And again, just like we saw in the dashboard, you can scale it independently. And when we're talking about scalability, that's another huge benefit. So instances, EC2 instances, take roughly between 30 and 60 seconds to start up, somewhere in that ballpark. Containers really are in the milliseconds, so we'll even round that up and say a second. So your scalability can rapidly respond to surges in demand. And then there's the feature velocity, a theme that we've been talking about. So if I have a number of changes that I want to go out, let's say one of them is a feature that an important customer has really been asking for. They want to get their hands on it. Or one of them might be a really important bug fix. Now, if I'm in the Majestic monolith, I just had to roll that whole thing back. I'm going to have to troubleshoot, diagnose, figure out what went wrong, and then so I can roll forward at some point in the future. So I've slowed down my feature velocity because one of any number of a set of changes had a problem. So again, just by making some really small changes, incremental, you can get a lot of these benefits, get these features out to your customers faster. We've been talking about a scenario where we were reactive. We deployed a new version, we encountered some problems, and then we reacted to it. Really, you want your DevOps to be proactive. Every week, you should be looking at your metrics, looking at those graphs, and identifying trend lines. You want to be able to spot where there are rises in latency over time, problems that are bubbling up, because if you can identify them when they're merely an issue versus you're hitting the panic button or rolling back, you're in a much better place. So the more that you can be looking ahead to see what's around the corner, you're in a better spot. These are the truly high value added activities that you can do with DevOps. So I think we spend a lot of time trying to automate, tasks such as deployments and things like that, again, which are all good. But if we can focus on these higher value add activities that DevOps gives us, bringing together the insight from operations into our development pipeline, incorporating those feedback and ideas, then we're in a much better place. Especially because there are tools out there that can help us do some of those deployment tasks and other things pretty easily. So one example, engine yard containers. Once you have made a change, just like you git push to the repository after you've set up your EYK application, you simply git push to the new EYK remote target. And that creates a container image of your application and deploys it based on the proc file that we showed you earlier and the specifications that you set up. Automatic scaling, all of the platform, load balancer, routing, all of that is set up for you. You can focus on what's really important, your application. Let's take a brief look at a few gems that you can use to track your customers' behavior, monitor usage, and get better insights to improve those operations that we just talked about. Ahoy and Blazor are two gems that I love. They're both very easy to set up and use, and you're going to get a lot of benefit from them. You can use Ahoy to track user visits to your web page, and also specific named events that you want to add to your code. You can do this from either the server side on a controller. You can do it from JavaScript as well. It's a simple API to use. Now, Blazor gives you visibility to your database. You're going to just add a mount point to your routes file so that you can access the web application. It gives you an easy interface to do SQL queries, show the results. So the Ahoy has two tables that it uses. You can easily query those. You can query any other tables as well. And it's got some smart built-in data visualization capabilities. So when you're doing selects of the form with 2 or 3 fields, and the third is a count, or you're including a timestamp, it can make some assumptions and do either a line graph, a bar chart, and you can see. So for example, here, I'm doing a query and looking at the different events, different user events over time for each day, seeing how people are using my, this is actually a poll, instant poll application that I use as another example. So very easy to use and set up. I encourage you to take a look at these. They're both from the same GitHub author and they're wonderful to use. Once you get those gems set up, don't just stop there. Be sure to check the metrics often. Look at them weekly, see what the trends are, and ask questions. This is the cool thing about operations is it's not always as well defined. It's a different type of problem to solve. When we are engineering and writing software, that's one type of problem solving. In this case, we may not even know what questions we should be asking, but it's well worth it to dive into that. It's going to benefit your customers for sure, but it's going to feed back into your development cycle. You'll be able to reevaluate things. Maybe earlier on, you looked at something and it wasn't worth breaking out into a microservice or even just giving more thought to the separation of concerns. But based on the usage and activity that you see or what your metrics look like, it may be worth doing that now. You can go back and reevaluate that. It's a really interesting feedback loop. Now, some of the tickets that you get, A lot of them may not be positive because someone submitted a ticket because they had a problem, but it's still rewarding in the fact that they cared enough to submit a ticket. They want to use what you've built. And you want the feedback because you don't want the next person to encounter that same problem. And again, it helps you direct where your attention and energy should go. So be sure to put all of these DevOps things into practice. It's not just about writing automation scripts. I really believe that this synergy is where the future of DevOps is at. A lot of the information for things that we've talked about here is on the Engine Yard blog, and you can also look for my Ruby Unbundled series. Really, it's just a fascinating language. I love working in the happiness bubble with Ruby on Rails, and so I write about a lot of topics in that space. I want to thank you all for your time. I certainly appreciate it, and I hope you all enjoy the rest of the conference.